Hi, grade 8. This is day 34, page 593, numbers 5 through 37, the odds. Today's lesson is about precision and significant digits. There's a lot in this text. The first thing they talk about is precision, how precise a certain measuring device can be. Can a measuring device be precise to the nearest inch, to the nearest half inch, to the nearest quarter inch, that sort of thing? Then they talk about significant digits. Pay special attention to the rules that are about 2 inches down on page 591. The third thing they talk about is how to add measurements and subtract measurements. That's on the bottom of 591. And then on the top of 592, they talk about multiplying and dividing measurements using significant digits as a factor. And that's different than the previous page where they're talking about adding and subtracting. So try to figure that out while you read through this. So I'm going to ask you to pause this, read through that section, then come back and we'll do a bunch of example problems to try to make this clear. Go ahead and pause right now. Thank you. Okay, hopefully you're back from reading through that section. Let's talk about precision for a few minutes. First, if I had a yardstick that looked like this, and I'm not going to draw the entire yardstick, so this represents the fact that the yardstick's going to continue in that direction. And if I had the number 1 right here and the number 2 right here, and this represented the distance of 1 inch, and this represents the distance of 2 inch, we would say that this measuring stick right now is precise to the nearest 1 inch. Precise to the nearest 1 inch. If I put a mark here and a mark here, now it's precise to the nearest half inch because we have half-inch marks. Half inch, half inch, half inch, half inch. If I put in a mark here, 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 and here, now I've made the item precise to the nearest quarter of an inch because we have quarter-inch marks. If I keep going, I'm putting marks in between each of those quarter-inch marks. Now it's precise to the nearest eighth of an inch, 1/8 of an inch. If I keep going and I put more marks, now we have a device that's precise to the nearest 1/16 of an inch. Okay, hopefully that helps you think through that. Let's do it with a different sort of thing. What if we're talking about, say, for example, a scale that measures with an arm that pivots, and right now the arm is pointed to 0 because nothing's on the scale yet. But what if I put marks here, 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 and I say to you that this represents marks. Nope. I want the numbers on the scale itself, so we're going to put the marks inside here. There we go. Each one of these marks represents pounds. Now we're talking about a scale that's precise to the nearest pound because there are no marks in between. Say, for example, the 1 pound mark and the 2 pound mark, or the 2 pound mark and the 3 pound mark. We could still estimate, but the amount of precision of this scale happens to be the nearest pound. If I do this and put marks here, 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 and here, now it's precise to the nearest half pound. Now, you happen to know that pounds are divided into 16 ounces. So what if I then take and try to divide this into 8 sections? Okay, it's kind of hard to see, but now I'm trying to divide this into the individual ounces, so this one would be precise to the nearest ounce, or precise to the nearest 1/16 of an ounce, because I'm dividing it into much smaller sections. Okay, let's move on to the section on 591 at the top, about 2 inches down, where they talk about the rules on figuring out significant digits. Do you see where it says 1.23 and 10.05 and 0.072 and 50.00? We're going to try to see if we can figure out, based on those rules, how many significant digits each of these numbers has. Okay? Starting with the number 400. Any idea how many significant digits this has? And please look at those rules to think through what the answer would be. In this case, the number 400 has just one significant digit. It's only the 4 that's significant. You do not consider zeros to the left of a decimal point significant unless there's another number other than 0 between the decimal point and those zeros. Right here, how many significant digits do you think this is? This is 3. How about here? This is 5. I'm basing this on the rules that are found on that page. Right here, this has one significant digit. This one has, believe it or not, 5 as well. That last 0 is considered significant because somebody considered it worthwhile to put down to show how precise one is measuring. This number right here has only 4 significant digits, even though it's identical to this number. These are the same numbers, but this one's precise to 5 significant digits, and this one has 4 significant digits. Meanwhile, this one right here only has 3 significant digits. And finally, this one down here also only has 3 significant digits. Up here, 4, then 5, then 5, and finally just 1. This kind of confuses people. Sometimes people look at this one and they say, you know, that should maybe have 4 or 3 significant digits. But according to the rules, it only has 1. Okay, now let's look how we apply this. If we look over here, we've got a number of math problems that we're going to work out using the rules on the bottom of 591 for adding and subtracting, and using the rules on the top of 592 for multiplying and dividing. Let's start with this first problem up here at the top. If I add those two numbers together, I get 17.5. But is that the answer if we want to think about adding according to significant digits? Well, if you look at the rules that are on that page for adding and subtracting, you need to think about how many decimal place values are involved in this. This one has 0 place values in the decimal slots. This one has 1. So the answer we want in this particular case is going to need to have 0 decimal place values, because we always adjust our answer based on the number that's part of the problem that has the least amount of decimal place values. This has 1, this has 0. So we need to make our answer also have 0 place values in the decimal slots. So somehow we need to get rid of this 0.5. Would we round this down to 17 or up to 18? I would round it up to 18. 1 decimal place value, 0 decimal place values. So our answer needs to have 0 decimal place values. So we change 17.5 to 18. Okay? Let's try this one right here. It's a subtraction problem. If I actually do the subtraction work on a, I'm going to grab a calculator here, make this as fast as possible. We get an answer of 4.325. We get an answer of 4.325. But we need to think about how many decimal place values there are. This one has 3, and this one has 1. The directions say we need to change our answer so that our answer only has 1 decimal place value. So that means the answer to this is 4.3. How about this one? Uh-oh, new set of rules. This is the set of rules for multiplying on the top of the next page. If I multiply these two numbers together, I'm going to get, let's see here, an answer of 54.0603. But look at how they do those problems on the top of the next page. We need to think about how many significant digits are involved. This number has 5 significant digits. This number has 1. Our answer needs to have the same amount of significant digits as the number that we multiply together that has the least amount of significant digits. In this case, our answer needs to have just 1 significant digit. So what's the closest number to this that has 1 significant digit? It's either the number 50 or the number 60. 50 is closer, so I'm going to write 50 as my answer. Let's look at this next one. It's an adding problem, so we're back to the bottom of, what, 591, I believe? If I add these 3 numbers together, let's see what I get. 6 plus 5.1 plus 7.28 equals, and of course the calculator and I are not getting along. Could probably do it faster by hand. I get 18.38 as my answer. But remember, according to the bottom of the page, we need to adjust our answer so that it has the same amount of decimal place values of the number that has the least amount of decimal place values. This one has 2 decimals, 1 decimal place value, 0 decimal place values. So this answer needs to change so that it has 0 decimal place values. What's the closest number to this that has 0 place values in the decimal slot? That would be the number 18. Okay? Top of the next column. We're back to multiplying. So let's multiply these 2 numbers together. I get 1,746.85. But top of 592, we need to think about significant digits. This number has 4. This number has 3. I need to change this answer so that it has 3 significant digits. What is the closest number to this that has 3 significant digits? That would be 1,750. Next one, we're back to adding. So we're going to add 29.056 plus 11.0 plus 17.95. And when I do that, I get 58.006. However, we're back to the bottom of 591, and the rules there say we need to find which one of these 3 numbers has the least amount of decimal place values. And that will be this one here. And we need to change our answer so that it also only has 1 decimal place value. And if I do that, I get an answer of 58.0. That's the closest number that has just 1 decimal place value to what the actual answer is. Let's do the next one. 40.02 times 14.8. I get, let's see, will that fit? 592.296. But we're back on the top of 592. We're multiplying. This one has 4 significant digits. This one has 3 significant digits. What can I change this number to so that it only has 3 significant digits? The answer is 592. And finally, our last one on the bottom here, also a multiplying problem. We've got 60.75 times 22.80, and I get a total of 1,385.1. But again, look at the rules on the top of 592. This has 4 significant digits. This has 4 significant digits. So our answer needs to have 4 significant digits. And our answer then becomes 1385, because that's the closest number to that has 4 significant digits. Okay, hopefully this helps you. If not, please give me a call. Thank you, and have a great day. Call me at 517-242-3138 if you're stuck.